Hello everyone, and welcome to a little bit more on trigonometry. Today we are talking about applications again, including what is called the angle of elevation and angle of depression. Those are two vocabulary words that you'll have to be using. And it just has to deal with basically when you look at things. When you look at things, sometimes you look up and sometimes you look down. And when you look up, that is called an angle of elevation. It's when you look forward. If you are looking forward, then if you start to look up, that angle that you are creating is called the angle of elevation, kind of like an elevator. If you were to picture in your mind an elevator, you were watching a glass elevator go up, then you are looking at an elevator, and then when it goes up, your gaze would follow that. And that's the angle of elevation, when you are starting to look up. That angle that's being created. It goes up, so you look at it, angle of elevation. So there it is, line of sight. When you are looking up, that creates an angle of elevation, versus an angle of depression, which is if you start to look down. So instead of looking up, you start to look down. But it's always being compared to where you are looking from. If you look down, then it's called an angle of depression. Depress means to go down. Or you can think about it, I'm sad, I'm depressed, so you look down. I don't know, but that's what depression is. It might be worth noticing for you that they are different vocabulary words, but when you look at it from these points of view, because it is the same figure, this angle right here, if you were to draw it on this picture, it turns out that they are the same angle. The reason for that is because this ground and this horizontal line right here are parallel to each other, so these would be alternate interior angles. So these angles actually are the same. So the angle that you are looking up towards is the same angle that if someone was up here, if they were looking down at you. So if you looked up at someone and they looked down at you, that's the same angle. It's just you looking up is angle of elevation, and them looking down is the angle of depression. So there you go. With angle of depression only, since the two horizontal lines are parallel, the line of sight is a transversal. Actually, that's just what I was saying, wasn't it? Okay, so let's try some problems. Hilltop. The angle of elevation from a point A at the top of the hill is 49 degrees. If point A is 400 feet from the base of the hill, how high up is the hill? Oh boy, that's a lot of words. So instead what I'm going to do is draw a picture. So I'll just draw a triangle. Boop, boop, boop. It is a right triangle. And we're just going to fill in the things it has. The angle of elevation. So remember, the angle of elevation is over here. It's how much, if this is flat, how much you're looking up. So it says the angle of elevation is 49 degrees. So that means I can label this 49 degrees. And it says from the point A. So that means this is supposed to be point A. If point A is 400 feet from the base of the hill, then, it's not saying that A is 400 feet from the top of the hill. So, this is apparently the hill or whatever, the hill is here. It's not saying that it's 400 feet from the top of the hill. It's saying it's 400 feet from the base of the hill. So it's trying to say that this is 400 feet. And then it's asking how high is the hill. So that's going to be this right here. This is what it's asking. How high is the hill? And this is, it's applications of trigonometry. So we are going to be using trigonometry. So we are going to have to be using SOHCAHTOA. And in SOHCAHTOA, you basically have to decide if you're going to use sine, cosine, or tangent based on this. So it is saying that we are using this angle right here. So I'm going to label them the opposite, adjacent, and hypotenuse. So the hypotenuse is right here. I'll use a pencil. This is the hypotenuse. This would be opposite, and this would be the adjacent to the angle. So we have the adjacent, and we're looking for the opposite, right? We're looking for the opposite, and we have the adjacent. So I want to use whichever one uses adjacent and opposite. And that would be this one, adjacent and opposite. So tangent. So we'll set up our equation. Tangent of theta equals opposite over adjacent. And now we're going to fill in what we know, right? Angle, the opposite, and adjacent. These are three different numbers. We will know two of the numbers, and we will find the third. So you ask yourself, do you know the angle? Did they give us the angle? And in this one, they did, right? They said it was 49 degrees. So the tangent of 49 degrees is equal to the opposite, which we don't know, over the adjacent, which was 400. So if you've watched my other videos, you know the sayings that I do. If x is up high, then you multiply, and if x is down low, then you switch, you know? And in this one, you know, the x is up high. It is this, the opposite, right? It's what we're looking for. It's like our x. So the x is up high, so we will multiply to cancel that out. And now it's just time for your calculator to do 400 times the tangent of 49. So first of all, on the calculator, do double check that it's in the right mode if you're using one of these. If you're using Desmos, then it should automatically be in degree, but otherwise you'll need to change it. And I'll just do 400 tangent 49, and there you go. 460, and does it say how high is the hill? 460 feet. It's about 460 feet, right? It's a word problem. Most likely no one's going to care. It's also 0.1 feet. No, so 460 feet. That is the height of the hill. There you go. Let's try another one. Air traffic. From the top of a 120-foot high tower, the air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. So how far from the base of the tower is the airplane? So here's my triangle. And what it's saying this time is that the angle of depression is 19 degrees. So if you remember the figure from here, with the angle of depression, it's supposed to be from this dotted line downwards. So if I made this dotted line downwards, this is supposed to be 19 degrees. So please don't think that this is 19 degrees. It's not. This is supposed to be 19 degrees. But from the thing I said before, is that if this is 19, then this is also going to be 19 degrees. So if it's easier for you, you can just put the 19 down there anyway. So from that, it says from the top of a 120-foot high tower. So basically, this is the tower. And if it is 120 feet tall, and this is 19 degrees, finally the question is, how far from the base? How far from the base? So is it asking for that, or is it asking for this? How far from the base? This is the base of the tower, and this is the airplane. So I guess it's asking for this right here. So this will be our x. So we'll do the same thing. SOHCAHTOA. This is the hypotenuse. Pause for a second, see if you can figure out the opposite and adjacent. This would be opposite, and this would be adjacent. We are looking for A, and we are given the 120. So those are the two we know, right? Hypotenuse is not labeled at all, but this was labeled X and this was labeled 120. So we are going to be using the two sides that we were given or are looking for. And that is O and A. Just like before, right? The last one we did O and A as well. So we're going to do tangent again. Tangent of theta equals opposite over adjacent. And we'll fill in what we know. So once again, I recommend pausing if you want to see what's going to go where. But here we go. Theta is 19. Opposite was 120. Adjacent was x. So what are we going to do to solve? Once again, I recommend pausing, see if you can anticipate what am I going to do. If x is up high, then you multiply. Well, x is not up high, right? X is in the bottom. Since x is not up high, we are not going to multiply. Instead, we're going to switch. So x is equal to 120 over the tangent of 19. So 120 divided by the tangent of 19. And there you go, 348.5. So 348.5 feet, approximately. And that's it. All right, I will go over both of these. Just pause it and see if you can try it first. Okay, here's the figure for the first one. As always, I draw my triangle. A ski run is 1,000 yards long with a vertical drop. So if this is a vertical drop, that's got to be here. Find the angle of depression. So once again, we can still just find this if we feel like it. This is going to be our x. Find the angle of depression, because this angle and that angle will be the same. And it says the ski run is 1,000 yards long. Find the angle of depression. So if the ski run, like when you're running and skiing, you're going down the slope. So that means this is supposed to be 1,000 yards. So the ski run is 1,000 yards. The vertical drop was 208. Find the angle of depression. But you're still going to do SOHCAHTOA. Labeling this one, this would be opposite, adjacent, and hypotenuse. We know this, and we know this. So we know opposite and hypotenuse. Which one is opposite and hypotenuse? Sine. So this time it is the sine of theta equals opposite over hypotenuse. And this time we do not know theta. This time the angle is what is missing. So sine of x is equal to the opposite over the hypotenuse. So if x is up high, we multiply. That's not the case. If x is down low, you switch to a note. Well, that's not the case. So in this one, you're not multiplying or switching. For this one, you're supposed to do the sine inverse. Whenever you solve for an angle, you do the sine inverse. So we're going to do the sine inverse. So I press second sine, and then 208 divided by 123, and it's about 12. So I'm just going to put 12 yards. There you go. I'm sorry, not yards, degrees. It's 12 degrees. Psh, silly Mr. Anderson. 12 degrees. The angle of depression is 12 degrees. So that's not a very steep hill at all. Yeah, 12 degrees is very small. So that means the slope was only like that much. That's a pretty small slope. Okay, last one. Once again, pause, try it. Or, pause at each step as we're going along. Your cat is trapped. Oh no! On a tree branch, 6.5 meters above the ground. So 6.5 above the ground. means that this is going to be 6.5 meters. Your ladder is only 6.7 feet. So the ladder is 6.7. Remember that the ladder is something you lean against the building. So this is going to have to be the 6.7 meters because this is the ladder. The ladder is what you lean. This is the ground. This is the tree. The tree. And this is your ladder, right? That you're going up. If you place the ladder's tip on the branch, what is the angle of elevation? So that is our x again. Okay. So what's next? Hypotenuse, opposite, adjacent. We know this one, and we know that one. Opposite and hypotenuse is going to be sine. Sine of theta equals opposite over hypotenuse. Theta is our x. Opposite was 6.5. Hypotenuse was 6.7. How do you solve? Doing sine inverse. Then you plug it in. Second sine, 6.5 over 6.7. And 75.96, etc. Let's see, if you place it, what is the angle? So it's an angle, you know, it's about 76 degrees. So I'm going to put 76 degrees, approximately. And there you go. That is the answer. Hopefully this is useful to you. Have a good one.